Now let us solve question number 33 from the practice sheet. Question number 33 says, in the given figure, AB and CD are two diameters of a circle perpendicular to each other, and OD is the diameter of a smaller circle. If OA is equals to 7, find the area of the shaded region. Okay, so there is a diagram given in this question. The diagram is question number 34. Oh, sorry, we have solved up to question number 32. Now it's time to solve the 33rd question. 33rd question. Okay, so question number 33, the diagram given is, there is a circle. In this circle there are two diameters. This is one, and let us say this is the second one. Okay, so let us assume that this is a center. This is O, and this is B, this is A, and this is C. CD is one diameter and AB is another diameter. So we have two diameters. Then we have drawn a circle with OD as the diameter. With OD as the diameter, I have drawn one more circle. This is the circle with OD as the diameter. Let us say the center of this circle is P. Okay, and it says that determine the area of shaded region. What is the shaded region? Here I have joined B and C. So BC is a chord and AC is also a chord. The shaded region in this question is this part, then this part, then this circle. Now I need to calculate these three areas. It is also given that OA is equals to 7 centimeters. Now what is OA? OA is the radius of this circle, which is 7 centimeters. If OA is 7 centimeters, OD is definitely also 7 centimeters because it is also the radius. Similarly, since OD is the radius of the larger circle, I can see that OD is the diameter of this smaller circle. And if OD is the diameter of this smaller circle, then what is the radius of this smaller circle? It will be OP or PD. So radius of this smaller circle is 7 by 2 centimeters, that is 3.5 centimeters. Okay. Now the area of this circle, can I calculate the area? Yes, it's very easy. What about this part? I can see that in the complete circle, this angle is 90 degree, that is OB and OC. The two radii are inclined at an angle of 90 degree with each other, and this is a sector of circle. In this sector, if I remove this triangle, we can calculate the area of this particular segment. Okay, this is the segment of the circle. So let us say this is the region 1, let us say this is the region 2, let us say this is the region 3. Okay, area of region 1, is equals to pi into 7 by 2 whole square. Area of region 2, since region 2 is a segment, so area of this segment is area of sector OCB sector minus area of triangle OCB. Okay, so area of region 2 is equals to, now what is the area of this sector? This angle is 90 degree. So area of sector is 90 into pi into r is 7 square upon 360 minus area of triangle OBC. Area of triangle OBC is half into r square, with that is 7 square into sine of angle 90. So this is the area of region 2. Similarly, I will say that since region 2 and region 3 looks symmetrical, so area of region 2 is equal to area of region 3. That's why, so this is also can be written as area of region 3. So I will say the total area will be equals to area of region 1 plus area of region 2 plus area of region 3. Okay, because region 2 and region 3 are segments of the circle. So using this concept, can you calculate the area of region 1, 2 and 3? Yes, it's simple calculation. I have substituted all the values. Now just solve this and calculate the answer. Okay, so this solves question number 33. Now let us discuss question number 34. Question number 34 says the area of an equilateral triangle ABC is 17,320.5 centimeter square. With each vertex of the triangle as center, a circle is drawn with radius equal to half the length of the side of the triangle. Okay. Find the area of shaded region. So question number 34. What it says is, there is a triangle. On this triangle, which is an equilateral triangle, I have drawn 3 circles with vertices of this triangle as the center in such a manner that the radius of each circle is equal to half the length of side of A, side of this triangle. If I say, let us say the side of this triangle is A centimeters. Okay, if the side of this triangle is A centimeter, then I have drawn 3 circles. I have drawn 3 circles like this. I have drawn 3 circles like this, and the radius of each circle is equal to A by 2. Okay, radius of each circle is equal to A by 2. This is like how the figure is. I will complete this circle, then this circle, and this circle also. I have drawn only this much part because this is our requirement. Now I need to calculate the area of this part. Now, how to calculate the area of this part? If I observe this triangle is an equilateral triangle, it's a plane figure. So let us say I take a sheet of paper and cut it in a way of this equilateral triangle ABC, and on this triangle, if I remove this part, upper part, and if I remove this part, I will be left with only this part, this shaded part. It means from the area of triangle, if I subtract these 3 parts, that is part 1 or region 1, region 2 and region 3, then I will be left with the shaded region. So what I can write is area of shaded region is equals to area of triangle ABC minus area of region 1, 2 and 3. Okay, if I subtract the area of these 3 regions from the triangle, I will get this area. Now, how to calculate the area of this region? This region, these 3 regions, we can see that this angle is 60 degree, this angle is 60 degree, this angle is 60 degree. Why they are 60? Because it's an equilateral triangle. Now, if B is the center, then definitely this line is the radius and this line is the radius. So what I can see is this is a sector of a circle, and the angle, the central angle of this sector is 60 degrees. Okay, this is a sector of a circle and the central angle of this sector is 60 degrees. This is also a sector of the circle. If you observe this part from this region, This is also a sector. So these three are the sectors of three different circles, but I will say the area of these three sectors will be equal. Why? Because area of sector is equal to what? It is theta into pi r square upon 360. So the area of sector depends on two things. First is the angle subtended at the center, and second thing the radius. If I observe the angle subtended by these three sectors, it is 60 degree, 60 degree and 60 degree. And if I observe the radius of these three sectors, the radius is, this is a by 2, this is also a by 2, and this is also a by 2, where a is the side of the triangle. Okay. So from this I can see that the area of all these three regions will be similar, it will be same, there will be no difference in them. So let us calculate the area of these three regions. Now how to calculate the area? For that I need angle, we have the angle, and one more thing, I need the radius, but I do not have the radius. So first let us think how to determine the radius. So our approach should be such that we need to determine the radius of the circle, and for radius I need the side of the triangle. Now can I calculate the side of the triangle? If I have any clue to calculate the side of the triangle, that is the area of the triangle. What is the area of an equilateral triangle? Area of triangle ABC is equals to root 3 by 4 a square, where a is what? A is the side of the triangle, and what is the area given? Area given is 17320.5. So let us solve this. It says that assume root 3 as 1.73205 is equals to, not is equals to, this is root 3 upon 4 into a square is equals to 17320.5. This is what it says. We need to assume this. Okay. Then, so let us remove this point. I will get 1, 2, 3, 4, 5 decimals, and if I remove this point, I will get 1 decimal. So in all, I will be left with 4 decimal. I can cancel these two values. This implies a square is equals to 40,000, and then a is equals to, this 4 will be 2, and the pair of 2 zeros, it will give you 200. So the side of the triangle is 200 centimeters. Okay, this is 200 centimeter. This is the side of the triangle. How we have calculated the side? We have used the concept of area, because the area of triangle is given. So we have used the area of triangle to calculate the side. Now we have the side. What is the radius? Radius of each circle is a by 2, that is 200 by 2, that is 100 centimeters. Now from this, what is the area of region 1, 2 or 3? Area of region 1 is equals to, theta is 60 degree into pi into 100 square upon 360. So this will give you 6. Now area of region 2, area of region 3 will also be same. So what I can write is area of region 1, 2 and 3, the total area of these three regions will be equals to 3 times of pi into 100 square upon 6. Okay, that is pi by 2 into 100 square. Now from this, can I calculate the area of shaded region? Yes, area of shaded region is equals to area of triangle, that is 17320.5 minus area of region 1, 2 and 3. The sum of area of region 1, 2 and 3 is pi by 2 to the bracket 100 square. Okay. So just what you need to do is, you need to solve this value to calculate the final area. What I have done is, I have assumed that this is region 1, 2 and 3. I can say they are similar, and how I have used the area of triangle to calculate the side of the triangle. If I get the side, I will get the radius. If I get the radius, I will get the area of 3 regions. And if I get the area of 3 regions, I will get the area of shaded region. So this is how we need to link the question. We need to think how to link the question, how to link different clues given in the question. It's like a puzzle, okay? So this is the solution for 34th question. First you note this, then we will continue. Okay, now let us solve 35th question from the practice sheet. Question number 35 says, on a square handkerchief, 9 circular designs, each of radius 7 centimeters are made. Find the area of remaining portion of the handkerchief. So question number 35 says, there is a handkerchief like this, and on this handkerchief, it is ABCD handkerchief. On this handkerchief, we have drawn 9 circular designs. 9 circular designs, and the radius of each design is 7 centimeters. So in this manner, we have drawn 9 circles. You can assume that they are circles, okay? So like this, we have 9 circles, and each circle has the radius of 7 centimeters, okay? 7 centimeter radius for each circle. I need to determine the area of remaining portion. Now what is the area of remaining portion? Remaining portion means from the area of square, if I remove area of these 9 circles, I will get the area of remaining portion. The remaining portion is this one. This is the remaining portion. This is the remaining portion. So how to calculate the area of this remaining portion? We will subtract the area of these circles from the square. For that, I need to have the area of these circles. Now, can I calculate the area of circles? Yes, I know the radius of circle. So I can very easily calculate the area. But do I know the side of this square? Till now, I do not know. So how to calculate the side of the square? Now, try to understand the approach that I am applying on this question. I am applying the approach that first I determine what I need to find. So this is what I need to find. Then I applied how should I find this. So I have applied the concept that yes, if I subtract the area of circles from the square, I will get the desired area. Then I thought how to calculate the area of square or area of circles. Okay. So this is a logical process. It's a step-by-step process to understand and solve this question. Okay, or any question of this chapter or any other chapter. So the point is that my shaded region, my answer depends on the area of square. So the area of square, I can see that these 3 circles are touching each other. Okay, so if I join the diameters of these circles, I will say that this diameter, this diameter, this diameter, they all are in the same line. Why they all are in the same line? Because the size of all the circles is similar. Size of all the circle is same. That's why. Now what is the diameter of this particular circle? The diameter is, radius is 7, so diameter is 14 centimeters. What is the diameter of this circle? It is 14 centimeters. What is the diameter of this circle? It is again 14 centimeters. So what is the side of the square? Side of the square is sum of these 3 diameters. So the side of the square is 14 into 3, 14 plus 3, sorry 14 plus 14 plus 14. So the sum of diameters of these circles give you the side of the square, and the side of the square will be 42 centimeters. Okay. So required area is equal to what? It is equal to area of square ABCD minus area of 9 circles. Since 9 circles are similar, so area of square ABCD will be equals to area of square, that is 42 into 42. So 42 into 42, this is the area of square, minus area of 9 circles. The area of one circle is pi into 7 square, that is pi r square, and 9 times. So 9 times pi into 7 square. So this is the required area in centimeter square. Okay. So what you can observe in this question is not at all difficult. The only thing that you need to understand is how to determine the side of this square. That is the analysis, that is analytics. Okay, you need to analyze this, you need to determine it yourself. No one will come to you and tell you that join these values and you will get the radius or diameter, because the questions will change. In this question it is given as a square and these are the circles. It may happen that you get a question in exam in which the triangular handkerchief, and on a triangular handkerchief there are squares joined in this way. Okay, so you need to analyze how to determine the unknown quantities. So this is the solution for 35th question. Let us discuss 36th question also. Question number 36 says OACB. OACB is a quadrant of a circle. Okay, OACB is what? It's a quadrant of a circle with center O and radius 3.5 centimeters. If OD is equal to 2 centimeter, find the area of first thing, that is the quadrant of OACB. Okay, quadrant OACB, and second thing, the area of shaded region. So question number 36, it says there is a quadrant. Now quadrant means angle 90 degree, that is the angle between the radii is 90 degree. So this is A, this is B, this is C, this is D, and this is O. So I need to determine this area as well as the area of this quadrant. Now it is also given that the radius is equal to 3.5. So radius means OB or OA, both are 3.5. This is 3.5 centimeters, and OD is given as 2 centimeters. Okay, OD is given as 2 centimeters. So first thing that we need to determine is area of quadrant OACB. Okay, OACB. Now what is the area of quadrant OACB? For that we will simply apply the area of sector, that is 90 degree into pi into r square, that is 3.5 square upon 360. So this will give you pi into 3.5 square divided by 4 centimeter square. This is the area of the quadrant OACB. Now after this I need to calculate area of shaded region. Now what is the area of shaded region? What you can see in the figure is, from the quadrant, if I subtract the area of this triangle OBD, okay, from the area of this quadrant, if I subtract the area of this triangle OBD, I will get the area of shaded region. So area of shaded region is equal to area of quadrant OACB minus area of triangle OBD. Now what is the area of quadrant OACB? Area of quadrant is pi into 3.5 square divide by 4 minus, now what is the area of triangle OBD? You can see OBD triangle, this angle is 90 degree. So we can see that this is the base of the triangle and this is the height of the triangle. So I can write area of triangle OBD is half into base 3.5 into height is 2. So this will give you this 2 and 2 will get cancelled. 3.5 to the bracket 3.5 pi by 4 minus 1 centimeter square. This is the area of shaded region, okay, in centimeter squares. This is the area of shaded region. So it's a very simple question. You can see there is no difficulty. Only the thing is the calculation of area of triangle, because this triangle is not because this area, the shaded part, is not a segment, it is a different figure. That's why I have applied area of triangle OBD and we have calculated the triangle in this manner. Okay, so this is the solution for 36th question. Okay, so first you note this, then we will continue.